Did you know that when you look into deep space, you're actually seeing thousands of years into the past? You're here now, drifting in the quiet cradle of this vessel, the soft hum of the engines settling around you like a warm blanket. Look out through the viewport, the faint shimmer on the hull, the distant glow of scattered starlight. It's all real, all reaching across impossible distances to meet your eyes. You've slipped far beyond home, past the moon, past the familiar patterns you memorized as a child. Out here, even a tiny blur in the dark could be an entire galaxy, holding billions of suns. And that quick flicker of light you spotted earlier, it might have been nothing more than a grain of cosmic dust burning away in silence. Just breathe. Let the scale of it settle into you. From this vantage point, those countless pinpoints of light feel endless, stretching out like a calm ocean of stars. The console beside you glows gently, brushing your face with a warm amber hue. Lean a little closer. Feel the slow, steady pulse of the ship beneath your feet. Every star you see, every single one needs, actually a close neighbor, a fellow member of our own Milky Way. Hundreds of billions more lie hidden far beyond the reach of your eyes. Those faint smudges, like the Andromeda Galaxy, are so distant their stars blend into soft, ghost-like clouds. You're seeing only a sliver of what's really out there. Strange thing about light, the stars you're watching, many of them aren't as they are now, but as they used to be. Their glow left centuries, sometimes millennia, before it ever reached this window. You might be looking at a star that no longer exists, a sun that has already collapsed or exploded in silence somewhere far away. Yet its final light still travels on, slipping through the dark to reach you. A quiet echo, a moment frozen in time. As you drift here, feeling the subtle, almost imperceptible sway of our vessel, let's cast our thoughts back to your home world. Polaris, the North Star, that steady beacon that has guided countless journeys across Earth's northern skies, often feels immutable, doesn't it? A constant friend. But even Polaris, so perfectly aligned above Earth's North Pole, is a fleeting guide in the grand cosmic dance. Our blue marble, you see, has a gentle wobble, a slow, majestic gyration on its axis, known as precession. Over vast stretches of time, thousands of years, this subtle shift repositions the stars in relation to our poles. Thuban once held the mantle of the North Star for the ancient Egyptians, and in roughly 12 millennia, the luminous Vega will take its turn. Nothing truly stays the same, does it? Even the stars, our ancient guides, shift their roles across the heavens. Imagine, for a moment, not this cozy ship, but a small wooden vessel upon an endless, dark ocean. Or perhaps a lonely caravan making its way across a vast, featureless desert. Before any magnetic compass, before satellite whispers, the celestial sphere was the only true map. Ancient mariners, like the Polynesian wayfinders, committed hundreds of stars to memory, their rising and setting points a precise, intricate choreography against the night. They passed this profound wisdom through generations, not just as technical guidance, but woven into songs, into sacred stories, so it could never be lost. That steady point of light, Polaris, or the Southern Cross in the opposite sky, were the anchors. Doesn't it stir something within you, knowing you're gazing upon the very same silent compass points that once steered explorers across continents and oceans? A heritage of wonder just hanging there. Now, let's gently shift our view towards that luminous, milky river stretching across the void. From Earth, on the clearest of nights, it's a breathtaking, hazy band of light, isn't it? Even from our current position, you can see it unfold, a cosmic tapestry woven from untold billions of stars. The reason for its distinctive shape is quite simple. We are asterisk inside asterisk it. Picture yourself at the heart of an immense, slowly turning disk, and you're peering outwards through its rim. That's our perspective. The countless suns, clouds of gas, and cosmic dust within that disk blur into this radiant, ethereal glow. Ancient cultures, in their wisdom, called it a celestial river, a pathway for spirits, the very backbone of the night. Each shimmering wisp, each soft glow, is another sun, another solar system, perhaps even another world. It's our galaxy, our home, and our endless horizon, all in one. And within that sprawling, misty river, within our own Milky Way, there lie not just the few thousand stars you can discern, but hundreds of billions more. Unseen suns, nestled deep within cosmic dust clouds, or simply too distant, too dim, too numerous to be individually resolved from our current vantage point. Think of the quiet immensity of it all, a silent, swirling ocean of stars, most of which we will never directly observe. It's humbling, isn't it? The sheer scale of life, of energy, quietly residing within the heart of our galactic home. We are but a speck, drifting gently through this cosmic masterpiece, surrounded by mysteries yet to be fully imagined. You might need a moment to just float here, letting that thought expand, filling the quiet space around you as the ship carries you onward, deeper into the dreams of the universe. The soft hum of the ship's engines is a constant companion, a gentle whisper against the vast silence of space as you drift further out beyond familiar orbits. Up here, amidst the muted glow of the console lights reflecting in the viewport, it's easy to forget just how densely populated our home galaxy truly is. We often talk about the Milky Way, but it's difficult to truly grasp the sheer number of suns that call it home, hundreds of billions, perhaps even more. Most are merely dim whispers, too far or too subtle to ever catch your eye without powerful magnification. Think of all those tiny, crimson-red dwarf stars, burning quietly, incredibly numerous, yet almost invisible, or the countless others shrouded behind immense veils of cosmic dust, their light only hinting at their presence when observed with special instruments. And imagine, if you will, the lonely journey of worlds untethered, drifting through the dark void without a star to call their own. From this vantage point, looking back at the familiar starfields we cherish from Earth, it's a profound realization. What you see is merely a fleeting glimpse, a tiny pinprick in a tapestry far grander than any human mind can truly comprehend. Our galaxy is so utterly brimming with solar fires that no single lifetime, no matter how dedicated, could ever hope to count them all. It's a comforting thought, in a way, knowing there's always more. Now, speaking of fleeting sights, sometimes from down below, you might catch a sudden flash of light streaking across the night sky, gone in an instant. We call them shooting stars, don't we? Funny how we name things, isn't it? But despite the magical feeling that brilliant, sudden flash isn't a star at all, it's usually just a tiny piece of cosmic debris, perhaps no bigger than a pebble, sometimes even just a grain of sand, burning up in the atmosphere. Imagine the sheer speed, tens of thousands of miles an hour, as it plunges into the planetary envelope below, the air compressing and heating so intensely it makes these fragments glow with an almost blinding brilliance before they simply disintegrate. Most never even make it to the ground. What we witness is their final, dramatic flourish, a quick, elegant farewell spark, in the vast, quiet canvas above. Some are remnants shed by passing comets, leaving dusty trails that Earth encounters annually. Others are simply random wanderers, adrift in the solar system for eons. They may be minuscule, but their light speaks volumes about the incredible energy and velocity of the universe. In every fleeting streak, space reminds us, with gentle insistence, that it is never truly still. Even from Earth's darkest corners, where human light doesn't intrude, the difference is staggering. Most of us live under skies, muted by the endless glow of cities, the ribbons of light from highways, and the persistent hum of artificial illumination. But journey to those rare, untouched places, remote deserts, silent mountaintops, isolated islands, and the heavens unveil themselves in a breathtaking display. Instead of a sparse scattering of bright points, the sky becomes a dense, living tapestry, thousands upon thousands of stars crowding the canvas. The Milky Way itself unfurls into a luminous, glittering arch, so bright you might even feel it casting faint shadows around you. It's here you can discern the ethereal smudges of distant galaxies, the glowing embrace of star clusters, and occasionally the delicate, almost painterly hues of nebulae. These places, astronomers fondly call them dark sky sanctuaries, are increasingly precious. To stand beneath such a sky is to connect with an ancient perspective, to see precisely what every human being before the advent of modern lighting witnessed, a universe truly alive with stars, humbling in its immense scale and breathtaking in its pristine clarity. Isn't it a shame, though, that for so many people across our world, the majestic river of stars that is the Milky Way has simply ceased to be a part of their daily lives? In our densely populated regions, the relentless tide of artificial light has effectively erased it from view. Entire generations are now growing up without ever experiencing that profound connection, that ancient wonder that was once so central to human culture, perhaps even to our very sense of place in the cosmos. Light pollution doesn't just dim the stars, it completely drowns them, leaving only the brightest planets and a handful of resilient points stubbornly twinkling through the perpetual haze. Cities that burn bright all night send their light upwards, scattering it throughout the atmosphere, creating this permanent, luminous veil. And the result? In some places, the Milky Way is, for all practical purposes, simply gone. Yet the stars are still there, aren't they? Waiting patiently just behind that luminous curtain. It's why astronomers and dedicated conservationists work tirelessly to preserve these dark skies, not just for the sake of scientific observation, but for the profound sense of wonder they inspire in all of us. To witness the Milky Way with your own eyes, truly see it, is to rediscover a view that belongs to the collective heart of humanity, a shared legacy across all time. Speaking of timeless views, the constellations, they feel so eternal, don't they? Their familiar patterns, passed down through generations, appear to be frozen in the vast celestial canvas. But here's a little secret from the void. Those stars that make up Orion, or Ursa Major, or Cassiopeia, are not fixed points at all, not even close. Each one is a traveler, gracefully navigating our galaxy with its own unique velocity, its own specific trajectory around the galactic center. Of course, because they are so incredibly distant, their individual motions are utterly imperceptible to us within a single lifetime. You might need a moment to just float here, letting that sink in. Yet, over tens of thousands of years, those familiar outlines we cherish will gently begin to warp and dissolve. Orion's distinct belt will slowly lose its perfect straight line. The Big Dipper, that iconic northern guide, will eventually bear little resemblance to its namesake. Astronomers can project these movements forward in time, painting a picture of how the sky will appear in the distant future, and it's truly wild. The constellations become nearly unrecognizable. The night sky, it turns out, is not a permanent portrait, but rather a magnificent, slow-shifting dance, a testament to just how dynamic and alive our galaxy truly is. Nothing truly stays still, does it? Now, if you were to journey to the southern hemisphere from Earth, crossing the equator in our silent ship, you would discover an entirely new celestial realm after sunset. For anyone raised under those familiar northern skies, it's like stepping into a different universe. Familiar friends, like the Big Dipper, simply vanish, dipping below the horizon, gone from view. In their place, new, striking shapes emerge. There's the Southern Cross, bright and compact, a timeless beacon for navigators of old. And nearby, those two ghostly smudges, the Magellanic Clouds, tiny satellite galaxies, gracefully orbiting our own, clearly visible to the naked eye. Entire new patterns of stars form constellations utterly foreign to northern stargazers. Perhaps the Emu, as recognized by indigenous Australians, or the majestic Centaurus, striding across the heavens. For those who call the southern hemisphere home, these patterns are as natural and instantly recognizable as Orion is to those in the north. It's a beautiful reminder, really, that the sky is a shared inheritance, but our perspective changes everything. Half of Earth beholds a view, the other half never does, and the universe above us is always, always larger than what we think we know. It's funny, isn't it, how much we assume is universal until we shift our viewpoint just a little. As we drift further, a faint, almost ethereal presence appears on the main screen, a misty blur you might easily mistake for a wisp of distant gas. Most galaxies lie utterly beyond the reach of human eyesight, yet one is close enough to generously reveal itself without aid: Andromeda. This hazy smudge, which seems so delicate and indistinct, is truly staggering in its scale. Andromeda is a grand spiral galaxy, much like our own, teeming with perhaps 1 trillion stars, stretching majestically for over 200,000 light-years across. Its light, that faint, almost shy glow we perceive, has been traveling for more than 2 million years just to reach us here. Now, think of that, 2 million years. Isn't that just like space, always offering whispers of ancient, immense beauty? Still, after all that incredible journey, you barely perceive it. Out here, with only the faint, recycled breath of your ship's atmosphere around you, you can direct your gaze towards a specific point in the inky tapestry of the void. And there it is, a barely there smudge against the velvet black, a ghostly wisp. That distant, hazy patch isn't just a cluster of stars. It's an entirely separate island universe, vast beyond imagining, floating, silent, and serene. Imagine seeing an entire galaxy with your own eyes, even if the ship's sensors are helping just a little asterisk to resolve its soft glow. It's humbling, isn't it? A soft hum from the console beneath your fingertips resonates with the quiet awe of the moment, the gentle play of starlight reflecting on the polished surfaces. That faint, ethereal glow has been traveling for an almost incomprehensible span of time, over 2 million years. Think about that. When those ancient photons began their solitary journey across the deep intergalactic ocean, Earth was a very different place. Our earliest ancestors were still taking their first hesitant steps, long before language or tools as we know them. Entire civilizations of creatures have risen and vanished in the immense span it took for that light to finally grace your eyes. And while we perceive Andromeda as it was eons ago, frozen in a moment, it hasn't stopped. No, it has continued its grand cosmic dance, shedding old stars and igniting new ones. You might need a moment to just float here, letting the stillness of the void settle around you, feeling the ship's subtle drift. So, when you consider the fleeting lifespan of even the most massive celestial bodies, it's a stark reminder that the glittering points we see aren't truly eternal. It's easy to assume they're fixed, unchanging beacons. But the universe is a dynamic place. Some of the stars, recorded by ancient watchers, peering through the earliest lenses of human wonder, no longer exist. They've lived their tumultuous lives and died, perhaps in a spectacular supernova that briefly outshone their entire galaxy, leaving behind only an invisible whisper of a neutron star or the silent, ravenous maw of a black hole. Nothing to worry about, probably. The gentle vibration of the hull beneath you is a quiet counterpoint to the distant, unseen cosmic violence. The night sky, then, isn't a static painting, but a continuously evolving story, a living record of what once was and what now is. Each tiny, shimmering point is inherently temporary, a brief, magnificent flicker in the grand cosmic scheme, even if its individual existence vastly dwarfs our own. Isn't that just like space? Look closely, and you'll even begin to discern their subtle variations in color, sharpened by the clarity of the void. Some burn with a deep, ruby-red intensity, their cooler surfaces radiating only a few thousand degrees. Others blaze with an intense, almost painful, blue-white brilliance, searingly hot, tens of thousands of degrees at their core. Our own sun, a familiar golden white, rests comfortably in the middle, a steady, dependable beacon. This spectral difference isn't just for show, you see. It tells an entire life story. By splitting the starlight into its constituent colors, much like a prism, we can decode a star's temperature, its chemical makeup, even how fast it's moving through space. From Earth, our atmosphere often mutes these subtle hues, making them harder to distinguish. But out here, suspended in the pure blackness, you see them with startling clarity, each one a unique jewel. Each color whispers secrets about its nature, its energy, its destined place in the immense, overarching cycle of the cosmos. The ambient temperature of the cabin feels perfectly balanced. A steady warmth contrasting with the icy vacuum outside, but mirroring the internal fires of these distant suns. Remember how stars twinkled from down on Earth, a delicate, magical shimmer. Out here, you won't see that. That enchanting sparkle we associate with night skies is actually just the turbulence in our planet's atmosphere, a constant, shifting dance of air currents bending and distorting the starlight as it struggles to reach our eyes. Planets, being closer and presenting a larger disk of light, usually appear much steadier, less prone to the atmosphere's playful nudges. Up here, however, the view is pristine, unwavering. Each star is a perfectly fixed point, a needle-sharp jewel against the absolute black. No flickering, no jumping. This absolute clarity is precisely why space-based telescopes, like the venerable Hubble, give us such breathtaking, detailed images of the universe. Freed from the distortion of Earth's restless, protecting blanket of air, they can capture the cosmos in its raw, unadulterated form. The steady glow reveals the true, vivid colors of stars, far more intensely than we ever see from the ground. While a twinkling sky holds a certain nostalgic charm, the view from orbit shows us the genuine face of the universe, stable, radiantly clear, and profoundly still. It's a powerful reminder that our atmosphere both shelters us and, paradoxically, gently disguises the true, unyielding beauty of space. And what creates all this incredible light and heat? Deep within the heart of every star, a fiery crucible burns, powered by nuclear fusion. For most of its immense life, a star diligently presses hydrogen atoms together, forging them into helium. But for the truly colossal stars, the process doesn't stop there. As their cores grow hotter and denser, they move on, fusing that helium into carbon, then oxygen, and eventually a whole array of heavier elements. Imagine that. Every atom of carbon in your very being, every molecule of oxygen you quietly breathe, was once forged in the heart of a blazing, long-dead star. The gentle, barely audible hum of your ship's life support systems seems to resonate with this deep cosmic process. Eventually, these cosmic behemoths reach their inevitable end, collapsing under their own immense gravity before exploding outwards, scattering these freshly minted elements across the vastness of space. These vital, stellar ingredients then become the seeds for new stars, new planets, and perhaps even new life. The cosmos is an astonishing, self-sustaining recycling system, isn't it? Each generation of stars gives birth to the raw materials for the next, a continuous, elegant cycle of creation and recreation. It's a quiet thought, drifting here, knowing you're a part of that endless, ancient process. Here we drift, you and I, a soft hum resonating through the ship's hull, a low thrum that becomes almost imperceptible after a while, just part of the quietude. Your gaze, perhaps, has already settled on that magnificent, distant gleam Sirius. It's more than just a star, isn't it? It's a furnace, a powerhouse, a forge shaping tomorrow's light. A subtle vibration courses through the deck plates beneath you, a gentle reminder of our journey as a faint console light casts a warm, orange glow across your hand. From this vantage, you can truly appreciate why the ancients called it the dog star. It absolutely dominates the velvet dark canvas, burning with an almost arrogant brilliance. That incredible sparkle, nestled within the sprawling constellation Canis Major, truly outshines nearly everything else. It's no wonder so many cultures, from the sun-baked lands of ancient Egypt to the distant Polynesian islands, wove it into their deepest myths. Think about it, a single point of light becoming a symbol, an omen, a cosmic guide through centuries. A stray thought, isn't that just like space, turning simple physics into profound poetry? It's close, only about 9 light-years away, but its intrinsic luminosity, shining more than 20 times brighter than our own sun, truly sets it apart. It even has a quiet companion, a faint white dwarf, a dense ancient heart orbiting it every 50 years, a silent testament to a long-past stellar life. Shift your focus just a fraction, a barely perceptible change in the ship's gentle trajectory. Ahead, sparkling like a scattered handful of diamonds tossed onto black velvet, you see the Pleiades cluster, sometimes called the Seven Sisters, or even Subaru, in a nod to its Japanese heritage. It's a tiny, intimate swarm of young blue suns. Through our viewport, they shimmer with a youthful eagerness, while you might only discern a handful with your naked eye, perhaps 6 or 7. A closer look through our augmented view reveals hundreds, each one a vivid, burning gem. The recycled air inside the cabin feels fresh, a steady stream against your cheek as you contemplate this familiar, yet always enchanting sight. This isn't some distant, faded memory of light. The Pleiades are relatively close, only about 400 light-years from us. See how they're still enshrouded in those ethereal wisps of dust. That faint, delicate glow around them isn't their own light, but starlight reflecting off those lingering cosmic clouds, creating a soft, almost shy radiance. It's a sweet reminder that not all wonders require vast distances to feel profound. Some of the most beautiful sights are intimate, almost within reach, a gentle whisper in the grand cosmic symphony. You might need a moment to just float here, letting their subtle beauty wash over you, a quiet awe settling deep in your spirit. Now, as the ship executes another delicate, almost imperceptible attitude adjustment, bringing a new vista into focus, allow your gaze to drift toward the mighty constellation of Orion. Follow his famous belt down, and there, within what's known as his sword, lies a truly remarkable sight. It's a faint, fuzzy patch of light, even visible to the naked eye from dark skies, but through our enhanced view, it resolves into something spectacular: the Orion Nebula. This isn't just a cloud. It's one of the galaxy's most vibrant stellar nurseries, a cosmic cradle where new stars are being born even as we watch. The subtle vibration through the hull seems to pulse in sync with the distant, gentle throbbing of creation. Those swirling, glowing gases you see are being illuminated by thousands of nascent stars, still finding their voice, shaping the clouds with their immense energy. To ancient stargazers, it was merely an enigmatic blur, a mystery. But now, we understand it as a dynamic workshop, a place where the universe continuously writes its next chapter. It's relatively close, only about 1,300 light-years away, making it a prime subject for study, a living laboratory of creation. Every glance here is a privilege, a peek into the very act of Genesis. Nothing to worry about, probably. Just the universe doing its magnificent thing, completely unconcerned with us. These grand canvases of the cosmos, these immense clouds of gas and dust, stretching for light years, come in many forms. Some, like the Orion Nebula we just admired, are called emission nebula. They glow with an internal fire, energized by the intense, powerful radiation, often ultraviolet light streaming from nearby massive stars. This energy excites the atoms within the cloud, causing them to emit their own colorful light. Think of them as immense, celestial neon signs, painting the void with vibrant reds from hydrogen, greens, and blues, depending on the elements present. The entire ship seems bathed in a faint, pinkish glow from the distant hydrogen, a warmth you almost feel. Without those energizing stars, these clouds would simply be invisible, fading into the dark, silent void. Instead, they blaze forth as luminous beacons, unmistakable signals of where stars are either being born or are living out their fiery lives. What appears delicate and soft, a mere brushstroke in the vastness, is in fact a roaring cauldron of activity, shaped by immense forces of energy and gravity into some of the most breathtaking sights astronomy has to offer. It's a gentle reminder that even the softest beauty often conceals incredible power. The faint engine hum below us seems to echo the distant cosmic symphony. But not all nebulae ignite with their own internal light. Some are more subtle, more understated. These are the reflection nebulae, delicate cosmic mirrors that simply scatter and redirect the brilliance of nearby stars. They shine with a softer, almost ethereal glow, often exhibiting a distinctive blue hue. It's the same principle that makes Earth's sky appear blue, scattering sunlight. Remember those faint dust clouds surrounding the Pleiades cluster we just observed? That's a perfect example where the young, hot stars illuminate the dust in a gentle, diffuse shimmer. The starlight reflecting off the hull makes the interior feel even more serene. These quiet beauties are often found near young star clusters, where plenty of bright, eager suns are ready to cast their light upon them. While perhaps less dramatic than their brightly glowing emission counterparts, reflection nebulae are exquisite in their quiet shimmer, a testament to the universe's capacity for subtlety as well as grandeur. They are the whisper to the other nebulae's shout, faint but undeniably captivating. Sometimes you find that the universe's most profound statements are delivered in the softest tones. And as you look out at the individual stars, it's easy to imagine each as a solitary beacon floating alone in the vast ocean of space. But reality, as it often does, offers a far more intricate ballet. Drifting effortlessly now, a soft glow from the console washing over the interior of our ship. You feel that gentle, persistent thrum beneath you, the quiet heartbeat of our vessel carrying us through the vast expanse. Out here, beyond the familiar, the cosmos holds countless secrets, and many of them revolve around companionship, even for stars. We often think of suns as solitary beacons, but the truth, as always in space, is more fascinating. Many celestial bodies are intricately bound, like cosmic dancers, orbiting a shared, invisible point. Some nearly identical in size, others a grand star gently guiding a smaller partner through immense, sweeping arcs. Often, to our unaided eyes back home, they'd simply appear as a single sparkle, their intimate connection hidden. But powerful telescopes reveal their elegant, dual nature. It seems our own sun, in its majestic solitude, might actually be the delightful rarity. It's almost a natural assumption, isn't it? To imagine most stars as single parents, perhaps with a family of planets, much like our own home. But surveys across the galaxy whisper a different story, suggesting that these stellar partnerships, these binary or even multiple star systems, are actually more common than solitary suns. Some were born together, cradled in the same swirling nebulae, their gravitational bonds forming at the very beginning, destined to endure for billions of years. Others, though, might have found each other later, drawn into an embrace through a chance cosmic encounter. Their relationships can be peaceful, a slow, harmonious waltz, or they can be spectacularly turbulent. Imagine the drama: a massive star playfully stripping gas from its smaller partner, forming radiant, swirling disks, or one collapsing dramatically into a white dwarf, a neutron star, or even a silent black hole, forever changing the dynamics of their ancient bond. And just think of the view from any world nestled within such a system. Life under two suns would paint a sky so profoundly different, wouldn't it? Two dawns stretching across the horizon each morning, perhaps a double sunset, a spectacular ballet of fading light and overlapping shadows. Our single golden sun, while incredibly special to us, is just one story in a galaxy brimming with celestial duets, trios, and even quartets. If two stars in a gravitational embrace seems complex, the universe, in its boundless creativity, frequently pushes the boundaries. Some systems host 3 or even 4 stars, weaving intricate dances. Picture a pair orbiting closely, while a third circles majestically further out, like nested steps in a slow, cosmic ballet. In quadruple systems, the arrangements can become astonishingly elaborate, with pairs orbiting other pairs. To us, they might just be a single, distant point of light, but our instruments reveal a miniature galaxy, a marvel in its own right, each one a testament to the cosmos' endless ingenuity. As we drift, the very air recycled around us carries a faint, familiar scent, a reminder of the contained serenity of our journey. Beyond our hull, beyond the familiar, there are other wonders, like the rhythmic pulsing of Schiphide variable stars. They don't just shine steadily. Instead, they expand and contract with a gentle, consistent rhythm, like cosmic lighthouses blinking across unimaginable distances. Their light brightens and fades in cycles that can last for days or weeks. To our eyes, they might just seem to flicker on an impossibly slow cosmic timescale. Yet, for astronomers, these stars are invaluable, a kind of cosmic heartbeat. The pace of their pulsation is directly linked to their inherent brilliance. By carefully measuring how quickly they pulse and comparing that to how bright they appear to us, scientists can precisely calculate their distance. It's truly quite remarkable, isn't it? What began as a curious observation of a star that seemed to breathe slowly in and out became one of the most powerful tools in cosmology. This revelation, quiet and unassuming at first, once entirely reshaped our understanding of the universe's true scale. For centuries, the sheer size of the cosmos was an unfathomable mystery. Were those distant stars merely pinpricks nearby, or were they unimaginably far? It was these very Cepheid variables that held the key. In the 1920s, a visionary astronomer named Edwin Hubble painstakingly studied Cepheids nestled within the Andromeda galaxy. By measuring their steady, reliable pulsations, he unlocked their true brightness, and from that, their astonishing distance. The discovery was staggering. Andromeda wasn't a nebula within our own Milky Way. It was another entire galaxy, an island of stars unto itself, impossibly far away. The universe, in that moment, expanded overnight, transforming from a single cluster of stars into a cosmos teeming with countless galaxies. These rhythmic beacons, these simple, pulsing stars, had bridged the gulf, revealing a universe far grander than anyone had dared to imagine. The gentle vibration of the ship's systems hums a quiet counterpoint to the distant, shimmering starlight. But not all stars are destined to remain small and steady like our sun. Some, as their ancient lives draw to a close, embark on a spectacular final act, swelling into titanic red supergiants. Imagine a star so immense that if it replaced our sun, its surface would extend far beyond the orbit of Mars. These celestial behemoths glow with a deep, weary red, their outer layers stretched thin as the star desperately struggles to maintain its balance against the crushing weight of its own gravity. Inside, in its core, it feverishly fuses heavier and heavier elements, burning through its fuel at an astonishing, glorious rate. They live fast and die young. These giants, while rare, their scale and brightness are unforgettable. To gaze upon one is to witness a star in its final, magnificent chapter, swollen, unstable, and destined for a dramatic collapse. And there, high in our familiar night sky, nestled in the shoulder of the mighty constellation Orion, burns Betelgeuse, a ruby-red jewel that has captured the imagination of stargazers for centuries. Betelgeuse is one of these red supergiants, already hundreds of times larger than our sun. Astronomers know, with a quiet certainty, that it is nearing the end of its immense life, having long ago exhausted the hydrogen fuel that once sustained it. Deep within its fiery heart, it now fuses heavier elements, building steadily towards an inevitable, glorious collapse. Betelgeuse's brightness often flickers dramatically, sometimes dimming so noticeably that it sparks whispers and speculation across worlds. It's a cosmic waiting game, isn't it? A truly magnificent spectacle in slow motion, played out on the grandest stage imaginable. You gaze out now, beyond the shimmering console lights that cast a soft glow across your hands, towards a particular star that captured imaginations back in our own corner of the cosmos. In 2019, this distant fiery orb, known to us as Betelgeuse, momentarily dimmed, its pulsating light flickering as if struggling for breath. Remember that brief collective gasp from so many watching eyes? It made us all wonder if its fiery heart was about to burst, a cosmic event that seemed imminent, though it soon returned to its familiar, pulsating brilliance. That moment served as a gentle whisper, a profound reminder of the fleeting nature of even the most immense celestial bodies. Betelgeuse, you see, is truly a star in its final act, a majestic elder moving gracefully toward its grand exit. Its fate, etched in the fabric of space-time, is irrevocably sealed. Whether it continues its luminous dance for another 100 millennia, or perhaps just a mere fraction of that, one thing is certain: its eventual demise will be nothing short of breathtaking. Imagine, for a moment, that magnificent star finally giving way, erupting into a supernova so brilliant it could momentarily outshine everything else in the night sky, perhaps even becoming visible during our own daytime. A spectacular final bow. When Betelgeuse finally reaches that cosmic crescendo, there will be no quiet fade into obscurity. Oh no, instead, it will unleash a colossal supernova, a detonation so incredibly powerful that for weeks, or even months, its dying light might dominate our heavens, outshining even a full moon. Can you picture that? Such events, mind you, aren't without precedent. Ancient stargazers once chronicled similar brilliant apparitions as nearby stars met their violent end. Betelgeuse, fortunately, drifts about 600 light-years away, close enough for us to witness its unparalleled splendor, yet comfortably distant enough to pose absolutely no peril to Earth. A cosmic fireworks display just for us. Once its light begins to dim after that ultimate explosion, a dense remnant will be all that remains, perhaps a neutron star, while its outer layers, rich with the very building blocks of life, will scatter at the very building blocks of loss, and autumn will scatter across the scales with spamps of sail, but so with the buas, with the sow, with the so, with the is so, it's of so to be you to ha, but you have you ba to have it to it to you side to will to you start with ba do but boo ka but who to do so do it just not to so at time by that with them but if it would you to pick up it with. They'll seed new generations of stars and planets. Isn't that just like space? When this cosmic farewell finally happens, humans across countless worlds will collectively turn their gaze skyward, observing that same dazzling beacon. It will be a timeless, universal reminder that even the most enduring stars, just like us, embark on extraordinary journeys, experiencing life and death in the most spectacular ways. The universe truly writes its grandest stories in starlight. It's almost impossible to grasp, isn't it, how a single supernova can, for a brief, glorious moment, outshine an entire galaxy. This death of a truly massive star stands as one of the most spectacularly violent events stitched into the fabric of the cosmos. You can almost feel the power, can't you, just by thinking about it? Deep within the star's core, an unimaginable collapse occurs, then rebounds with such ferocious energy that the entire star is quite literally ripped apart in a single, terrifying instant. All that stellar matter flung outward for a fleeting period. The sheer energy unleashed by such an explosion can actually surpass the combined output of the other stars in an entire galaxy. Imagine trying to comprehend that scale. From a distant vantage point like Earth, these cosmic bursts might simply materialize as new, impossibly bright stars, where previously there was only empty blackness. Some of these celestial fireworks might dwindle within weeks, while others could linger in the night sky for months. A prolonged farewell, nothing to worry about, probably. Beyond their sheer spectacle, supernovae serve as the universe's ultimate engines, relentlessly scattering the heavy elements forged in those stellar hearts into the surrounding void. These are the very ingredients, carbon, oxygen, iron, that form planets, moons, and ultimately life itself. Without these magnificent, violent deaths, the fundamental building blocks of everything we know, including us, simply wouldn't exist. The brilliance of a supernova might be ephemeral, a flash in time, but its profound legacy truly echoes forever. To truly contemplate an entire galaxy temporarily eclipsed by the demise of one single star is to confront both the unfathomable power and the gentle impermanence that defines the cosmic ballet. You might need a moment to just float here, letting that sink in. It's a humbling thought, isn't it? The universe showing us its true, untamed nature. Now, let's shift our gaze to a tangible echo of such an event, a magnificent cosmic scar that graces our skies. You're seeing it on the main display now, a swirling, ethereal beauty known as the Crab Nebula. It's the direct remnant of an explosion that was carefully chronicled in the night sky by keen-eyed astronomers from ancient civilizations. Back in the year 1054, observers across China and around our world meticulously documented the sudden appearance of an incredibly dazzling new star. Imagine the awe, the confusion. That unexpected visitor shone with breathtaking intensity for weeks, vivid enough to be seen even during the full light of day before it gradually, gently faded from view. Today, thanks to our expanded understanding and tools, we know that spectacular apparition was indeed a supernova, the dramatic, fiery death of another massive star. Its lasting legacy still hangs in the heavens, swirling before us, forever known as the Crab Nebula. It's a cosmic fingerprint, isn't it? Through the advanced optics of our ship, it appears as a breathtaking, tangled web of glowing filaments, a vast, expanding shell of gas and cosmic dust violently cast off by that ancient explosion. And right at its heart, nestled within that chaotic beauty, lies a pulsar. This is the collapsed, furiously spinning core of the original star, still relentlessly sending out precise pulses of radiation, much like a steadfast, unwavering cosmic lighthouse blinking across unimaginable distances. The Crab Nebula, in essence, is a living time capsule, a shimmering, incandescent bridge connecting those ancient records to the marvels of modern astronomy. When we witness its shimmering expanse, we are simultaneously peering into the memory of a star's magnificent, violent passing and the enduring, quiet life of its exotic remnant. It's a testament to how the universe remembers and how its stories continue to unfold forever. You feel a slight, almost imperceptible shift in the ship, a gentle nudge as we adjust our trajectory, carrying us deeper into these cosmic curiosities. Think for a moment, about those pulsars, those astonishing remnants that spin with a precision that truly rivals our most advanced atomic clocks. They are, without exaggeration, among the strangest, most mind-bending objects scattered throughout the cosmos. Each one is the hyperdense, collapsed core of a massive star, all that's left behind after a supernova has ripped its outer layers away. Composed almost entirely of neutrons, these stellar husks are unimaginably dense. To give you a sense, a mere teaspoon of pulsar matter would weigh as much as an entire mountain back on your home world. Can you even begin to picture that? Many pulsars twirl at absolutely astonishing speeds, hurtling through space and sending out focused beams of radiation that sweep across the universe, just like the steady, unwavering light of a cosmic lighthouse. From our vantage point, these energetic sweeps appear as incredibly regular pulses of light or radio waves, each one arriving with such flawless reliability that astronomers can use them as the universe's own perfect timekeepers. Isn't that just like space, always giving us these little marvels? Some pulsars complete dozens of rotations every single second, while the most frenetic among them whirl hundreds of times in that same blink of an eye. Their unwavering stability really does put Earth's finest atomic clocks to shame, allowing us to measure cosmic distances with incredible accuracy and even put the very laws of physics to the ultimate test. These tiny, collapsed remnants, no bigger than a city, serve as profound reminders that time itself, in its deepest, most fundamental sense, can be found etched in the enduring dance of starlight. It's a comforting thought, a rhythmic beat in the quiet expanse of the void. And now, as we gently drift deeper into this silent tapestry of stars, let's consider another marvel, even more extreme than the pulsars, the magnetars. These particular, exotic remnants of dead stars truly stand in a league of their own. Like their pulsar cousins, they are indeed neutron stars, but they possess magnetic fields so incredibly intense, so utterly vast, that their power frankly defies our easy comprehension. The magnetic field of a magnetar is not just strong, it's trillions of times more potent than Earth's own protective magnetic shield. This colossal magnetic force is so overwhelming, it's capable of physically distorting the atomic structures of matter itself. Imagine that. These fields can twist and snap with incredible violence, unleashing sudden, powerful bursts of high-energy radiation that rip and ripple across the boundless expanse of space. Astronomers detect them as momentary, almost startling flares, brief, yes, but immensely powerful. It makes you wonder, doesn't it, about the raw, untamed forces out here. Though surprisingly small, perhaps only about 20 kilometers across, barely the size of a city, these compact titans still pack the mass of multiple suns into their tiny spheres. Their sheer magnetic strength makes them incredibly dangerous, even across vast cosmic distances. A magnetar toying too close to our home world, for instance, could wreak absolute havoc on Earth's delicate magnetic field. Fortunately, and quite reassuringly, there are no such colossal magnets lurking in our immediate neighborhood. Nothing to worry about. Instead, they remain distant, fascinating curiosities, functioning as nature's own extreme laboratories, where the fundamental rules of physics are pushed to their absolute breaking point. Magnetars, in their quiet, terrifying brilliance, demonstrate that the universe is not merely expansive, but also utterly capable of producing forces so extreme, so beyond our everyday experience. They truly border on the unimaginable. It's a good thing we're so far away, isn't it? As we settle into this quiet drift, letting the faint engine hum lull you, let's turn our thoughts to the ultimate cosmic enigma, the black holes. They are the unseen giants, lurking silently in the night sky, their presence revealed not by their own light, but solely by the profound effects they have on everything around them. You see, a black hole isn't something we can ever directly perceive. Its gravitational pull is so utterly overwhelming that not even light, the fastest traveler in the universe, can escape its grasp, rendering it perfectly invisible against the infinite backdrop of space. It's like a secret that the universe keeps close, yet their immense presence is absolutely undeniable, precisely because of what they do to their surroundings. Imagine matter, perhaps a star's gas, caught in its relentless embrace, spiraling inward, faster and faster. As it approaches that final precipice, it heats up to unimaginable temperatures, glowing fiercely in X-rays before vanishing beyond the point of no return. You can almost feel the pull, can't you? Stars themselves, if snared in their invisible grip, might orbit an unseen companion, their erratic dance betraying the immense hidden mass of the black hole. Even the very fabric of space itself curves inward around them, distorting and warping the paths of light from more distant stars, creating strange, beautiful lenses across the void. To the unaided eye, black holes remain utterly invisible, profound absences in the starlit canvas. But through our sophisticated telescopes and patient, meticulous observation, astronomers have painstakingly uncovered countless numbers of them, scattered throughout our galaxy and beyond. Some are the dense, collapsed remnants of those very massive stars we discussed, while others, truly gargantuan in scale, lurk with silent, terrible majesty at the very hearts of galaxies, acting as their gravitational anchors. They are the unseen architects, the powerful, silent conductors of vast cosmic dramas, a final, beautiful reminder that the most profound and powerful forces in the universe are often those that remain hidden, always just beyond our direct sight. You can just rest now, letting the vastness hold you. The subtle hum of the ship's engines is a constant, gentle lullaby, a soft vibration you can feel deep in the deck plates beneath you, echoing the quiet thrum of the universe itself. Out there, in the silent, inky canvas, forces beyond our comprehension often cloak themselves in shadow and stillness. Yet some among them are voracious, devouring nearby stars and erupting into brilliant, furious flares as they feed. Imagine a colossal unseen presence drawing tendrils of gas from a companion sun, pulling it into a mesmerizing, spiraling embrace. This stolen starlight doesn't vanish. It forms an accretion disk, a magnificent, whirling ring of superheated matter, glowing at temperatures so extreme they emit powerful X-ray radiation. This is how an otherwise invisible behemoth becomes one of the brightest objects at specific wavelengths, a flickering beacon in the cosmic night, sometimes blazing, sometimes dimming, depending on its stellar meal. Sometimes these titans even unleash incredible jets of material, blasting near the speed of light across thousands of light years. While the thought of a star being consumed might sound apocalyptic, it's all part of the universe's grand recycling ballet, redistributing energy and matter, revealing these dark hearts as not mere voids, but active architects of galactic destiny. Right at the silent core of our own sprawling galaxy, the Milky Way, lurks just such a colossal force. You can't see it directly, no, but you can feel its profound influence, like an invisible anchor. Sagittarius A** is its name, a supermassive black hole with a mass millions of times greater than our Sun. Its presence revealed by the frantic, dizzying orbits of stars whipping around it at mind-boggling speeds. It's quite the cosmic ballet, isn't it? Just a few years ago, in 2019, clever minds finally managed to capture its shadow for the very first time, an image cobbled together by a network of radio telescopes spanning our entire world. What they saw was a luminous ring of superheated light, matter, trapped in its final inward spiral, surrounding an absolute void where even light itself surrenders. These colossal black holes are thought to reside at the heart of most galaxies, quietly shaping their evolution through their immense gravity and boundless energy. Knowing our own galactic home is tethered to such an awe-inspiring power is profoundly humbling. It's the unseen, yet utterly influential heart of our Milky Way, beating to a silent cosmic rhythm. Beyond our immediate cosmic neighborhood, the night sky stretches into an expanse that holds more than just individual stars. The twinkling lights we see are merely the beginning, a shimmering veil. Far past the familiar spiral arms of our Milky Way, countless galaxies populate the universe, each one a vast island universe containing billions, sometimes even trillions, of stars. Through the quiet magic of our telescopes, those faint, smudged patches of light resolve into intricate spirals, shimmering clusters, and elegant ellipses. Imagine, if you will, the Hubble Space Telescope once stared into a seemingly empty patch of sky, no larger than a grain of sand held at arm's length for days on end. What it revealed was absolutely astounding. Thousands of hidden galaxies, each one a universe unto itself. This discovery completely transformed our understanding, showing us that everywhere you look, the universe is simply overflowing with these magnificent structures. With the naked eye, you might only glimpse a few, like the distant Andromeda or the ethereal Magellanic Clouds. But with the right tools, the vast, quiet blackness between the stars blossoms into an endless ocean of light. The night sky is not just a canopy of stars, but truly the edge of a vast, boundless universe of galaxies. As we drift past, you notice the subtle shift in the cabin's recycled air, a faint breeze stirred by the ship's slow course correction, almost imperceptible. Each of these island universes, these galaxies, is remarkably unique. They're certainly not all alike, you see. Some form graceful, sweeping spirals, their arms adorned with vibrant young stars and swirling gas, curving elegantly outward from a brilliant core. Others are smooth, almost featureless ellipses, vast, serene balls of ancient stars, glowing with a soft, timeless light, perhaps the result of ancient, quiet mergers. Then there are the delightful misfits, the irregulars, their shapes wonderfully chaotic, often distorted by past cosmic collisions or sudden, vibrant bursts of new star formation. Each distinct shape tells a profound story about its own history, its cosmic journey across billions of years. Spirals are often active, bustling with stellar nurseries. Ellipticals are typically older, more sedate, often the product of grand mergers. Irregulars are still finding their way, still settling. Isn't that just like space? The diversity seen through our lenses is absolutely astonishing. Some burn brightly, others appear as whisper-faint smudges, barely discernible. Yet every single one is a universe of its own, brimming with stars, planets, and mysteries that defy counting. To witness them is to truly grasp the cosmos's endless inventiveness. shaping both order and chaos into luminous, drifting forms that dance through the profound darkness. And speaking of dances, while the distances between individual stars within a galaxy are truly immense, galaxies themselves are rarely isolated, solitary beings. Oh no, they are intricately bound by gravity into sprawling clusters and groups, and their vast, graceful paths often intersect. When galaxies collide, it's not the explosive, violent crash you might imagine, but rather a breathtaking, slow-motion ballet unfolding over hundreds of millions of years. Their individual stars mostly sail past one another, undisturbed, but their vast clouds of gas and dust dramatically collide, igniting furious bursts of new star formation. Gravity stretches their shapes into magnificent ethereal spirals, flowing tails, and shimmering arcs. Over eons, these magnificent dancers eventually merge, becoming one colossal, grander system. Our own Milky Way, believe it or not, is destined for such a fate, on a collision course with the majestic Andromeda galaxy. Far, far in the future, the two will become a single, massive, elliptical galaxy. For now, we simply watch others in the distance, their cosmic ballets gracefully frozen in time for our viewing. Each collision is a quiet, profound reminder that nothing in the universe is truly static, not even the galaxies themselves. You might need a moment to just float here, letting that sink in. Peering out now, perhaps from a different viewport, you might notice the reflections of distant starlight dancing softly across the control panels, a gentle shimmer against the steady console lights. If you were viewing from the southern hemisphere, to faint, cloud-like patches of light would linger near the Milky Way, just at the edge of your vision. These are the large and small Magellanic Clouds, delightful dwarf galaxies quietly orbiting our own. To the naked eye, yes, they appear as subtle smudges, almost like wisps of vapor, but through our telescopes, they unveil themselves as bustling, vibrant systems, absolutely teeming with their own stars, clusters, and glowing nebulae. Their shapes are wonderfully irregular, gently distorted by their intricate gravitational dance with the Milky Way, a cosmic tug-of-war. Within them lie incredible stellar nurseries, like the famous Tarantula Nebula, one of the most active star-forming regions we know. For observers in the north, these companions remain invisible, forever hidden below the horizon. But for those in the south, they are familiar, ancient companions, woven into cultural traditions for centuries. These miniature galaxies serve as a beautiful reminder that the Milky Way is never alone. We are part of a larger, interconnected family of galaxies, orbiting, merging, and subtly shaping one another across the vast expanse of cosmic time. The ship itself seems to sigh, a subtle, almost imperceptible shift in its position, adjusting to some unseen gravitational whisper. Not all stars, you see, choose to live in isolation. Many are born together, bound by an invisible, powerful force, gravity, forming glittering cosmic families known as star clusters. These clusters can range from intimate gatherings of just a few hundred stars, like close-knit communities, to truly massive groups containing thousands upon thousands, all twinkling together in the cosmic dark. Take, for instance, open clusters, such as the famous Pleiades, that familiar sparkling jewel box in the night sky. They are typically loose, youthful assemblages, their brilliant stars still relatively close to their birthplace, not yet having drifted far from their siblings, shining with the fresh, vibrant energy of youth against the profound ancient backdrop of the cosmos. Their faint glow barely penetrates the ship's hull, a cool light against the slight warmth from the consoles. As we continue our slow, deliberate glide through the cosmic ocean, a different kind of marvel begins to reveal itself, far more ancient and densely packed than the wisps of gas we left behind. You feel the almost imperceptible tremor of the ship's engines, a faint, reassuring hum beneath your seat as our viewports adjust. Before us, scattered across the inky blackness, are luminous, spherical gatherings of stars, glowing like precious pearls flung onto velvet. These are the globular clusters, incredibly old families of stars, each one a tightly bound community of light. You lean closer, perhaps catching the soft reflection of the console's gentle lights on the glass, mesmerized by their concentrated brilliance. Through our enhanced optical sensors, what might otherwise appear as mere sparkling knots explodes into a breathtaking tapestry of individual suns, each a story untold, a world unvisited. The recycled air feels cool against your face as you contemplate their sheer density. These clusters are living laboratories for those who seek to understand the very fabric of existence, holding secrets to stellar evolution and the grand sweep of galactic history. To witness one is to see a family held together by gravitational forces that have reigned supreme for billions of years, a testament to cosmic unity. They can house hundreds of thousands of stars, perhaps even more. Isn't that just like space? Indeed, these spherical marvels are among the most spectacular sights you can encounter. Imagine hundreds of thousands, sometimes millions, of stars crammed into a space barely a few dozen light years across. In their very hearts, the density is so extreme that individual stars blur into a continuous glow, like a swarm of brilliant fireflies caught in an eternal dance. You might feel a subtle shift in your seat as the ship makes a minor course correction, bringing another cluster into clearer focus. Most of these ancient formations orbit the remote outskirts of galaxies, our own Milky Way hosting well over 100 of them. They are truly ancient, often surpassing 10 billion years in age, containing some of the oldest stars in existence. What you're gazing upon are not just stars, they are cosmic fossils, survivors from the very epoch when galaxies first began to take shape. While a distant, faint, fuzzy patch to the unaided eye, our systems reveal them as dazzling, profound globes of light. Their beauty isn't merely in their glittering display, but in their extraordinary endurance across cosmic history. Some of these clusters are nearly as old as the entire universe itself, dating back more than 12 billion years. You feel a soft vibration resonate through the hull, a quiet reminder of our incredible journey. Nothing to worry about. Probably, these are true time capsules, preserving the earliest stars ever formed. These primordial suns contain remarkably few heavy elements, reflecting an era before supernova had enriched the cosmos with the crucial ingredients for planets, and indeed for life as we know it. To study them is to peer back into a nearly primeval universe, a time when the very first stars were flickering into existence against the nascent dark. The sheer fact that these clusters still exist today, gracefully orbiting the periphery of galaxies, speaks volumes about their astonishing resilience. They have weathered countless galactic mergers, collisions, and gravitational disturbances, yet they remain wonderfully, stubbornly intact. Why does the universe always do this to you? When you truly gaze at one, you are not simply seeing stars. You are witnessing glowing beacons, relics from the dawn of time itself, enduring witnesses to creation. Now, let's shift our gaze, or rather, our focus, to a phenomenon that touches closer to home, a celestial ballet that our blue-green planet experiences regularly. Imagine the Earth, our distant home, as it journeys through the vastness, occasionally crossing the ghostly trails left behind by comets. Several times a year, our world dips into these streams of cosmic debris. As we move through them, countless tiny particles, no bigger than grains of sand, collide with the Earth's atmosphere. They ignite, burning up in brilliant flashes, creating what we know as meteor showers. You might need a moment to just float here, picturing it. Unlike the occasional, random shooting star, a meteor shower brings a magnificent flurry of streaks across a single night, all appearing to radiate from a specific point in the sky. Think of the Perseids, the Geminids, or the Leonids, famous names, each linked to a parent comet or asteroid. These celestial events are remarkably predictable, gracing our skies on the same dates year after year as Earth faithfully revisits these cosmic pathways. For stargazers on Earth, they are among the most rewarding spectacles, filling the heavens with fleeting ribbons of light, though these tiny visitors are often no larger than sand grains. Their fiery descent is a vivid reminder that Earth is perpetually in motion, dancing through a living solar system, always intersecting with the ethereal remnants of ancient wanderers. The Perseid meteor shower, which graces August skies, is undoubtedly one of the most cherished. Every August, a spectacular display of shooting stars reliably unfolds, originating from the dusty wake of Comet Swift-Tuttle. The shower remains active for weeks, but it truly peaks around mid-August, when observers under dark, clear skies might witness dozens of meteors per hour, sometimes even more during particularly intense bursts. The Perseids are renowned for their bright, rapid streaks, many leaving behind glowing trails that linger for precious moments, like ethereal brushstrokes on the canvas of night. As you watch the simulated view on the main screen, you can almost feel the gentle shift of gravity, a quiet reassurance of our journey. These radiant streaks seem to burst forth from the constellation Perseus, hence their poetic name. For centuries, humanity has watched the Perseids, weaving them into folklore and marking them as a cherished highlight of summer nights. Today, they remain a favorite for stargazers across our home world, combining comforting predictability with breathtaking beauty. Each meteor is a tiny, ancient fragment of a comet, burning brightly as it falls, a yearly reminder of the profound intrinsic connection between Earth and the boundless cosmos. You can almost hear the soft hum of life support systems, a gentle presence in the quiet interior of our ship. Meteor showers, it seems, have never gone unnoticed by history. Ancient Chinese, Korean, and European texts meticulously describe sudden, spectacular bursts of falling stars, sometimes numbering in the hundreds on a single night. These records often carried deep symbolic weight, interpreted as powerful omens or portents of grand events to come. Imagine the sheer awe or even terror of witnesses during a famous Leonid shower in the 1830s, when thousands of meteors per hour filled the sky with blazing streaks, prompting some to believe the world itself was ending. You feel a subtle, almost imperceptible sway of the ship, a reminder of the quiet void outside. For contemporary astronomers, these historical accounts are far more than mere curiosities. They serve as invaluable tools to track the intricate orbits of comets and map the long-term evolution of meteor streams. By carefully comparing these ancient records with modern observations, scientists can understand precisely how these debris trails spread and shift across centuries. What was once perceived as mysterious fire in the sky is now recognized as a predictable cosmic event. Yet, the wonder endures. Even today, when meteors fill the heavens, they still inspire that same profound sense of awe, that quiet astonishment at the universe's grand display. Among these celestial displays, the Geminids stand out as truly unusual, born not from a delicate, icy comet, but from something stranger, an asteroid. Most meteor showers are indeed gifts from comets' fragile, icy wanderers that gradually shed long, dusty trails as they orbit the sun. But the Geminids, one of the year's brightest showers, trace their lineage to a rocky, compact parent body known as Phaethon, which behaves more like a burnt-out comet than a typical asteroid. As it draws near the sun, Phaethon releases dusty debris that Earth later crosses each December. When those tiny grains inevitably slam into our atmosphere, they ignite in a brilliant spectacle, creating the Geminid meteors. Unlike many other showers, the Geminids are celebrated not only for their incredible intensity, but also for their dazzling variety of colors, flashing across the night sky in hues of white, yellow, and even vibrant green. At their peak, you might witness hundreds of meteors, and sometimes, just sometimes, you might witness something truly remarkable flash across the profound darkness of the cosmos. So bright, it briefly outshines even the constant glimmer of the instrument panel. These aren't your typical, fleeting wishes on star. These are meteors of an altogether different grandeur. Imagine a fragment, perhaps no bigger than your fist, yet it burns with an intensity that can momentarily rival Venus, that brilliant beacon in the twilight sky. We call them fireballs, and their momentary brilliance is so profound it can cast faint, fleeting shadows on a landscape below, illuminating the night like a brief, silent explosion. Isn't that just like space? To hold such immense energy in something so small, they often leave behind delicate, glowing trails that linger for just a moment, a cosmic signature quickly erased by the void. But then there are those rare instances, perhaps once in a lifetime, when a fireball transcends its own brilliance and becomes something even more spectacular, a bolide. This isn't merely a flash of light, it's a detonation. You'd feel the soft vibration through the hull, a subtle tremor, as if the universe itself just stretched. Then a silent, brilliant flash from a distance, rivaling the sun's own intensity. On a planet's surface, this isn't silent at all. It's a resounding boom, like rolling thunder, powerful enough to rattle windows and shake buildings, as people on Earth experienced not so long ago. These are larger fragments, meters across, hitting an atmosphere at unimaginable speeds, violently fragmenting and releasing incredible stored energy. Ancient tales speak of fiery skies and booming noises. Surely these were bolides, a stark reminder that even as we drift, Earth is constantly navigating a cosmic shooting gallery. Yet, most of the time, the dance of debris around a world is far more subtle, a quiet whisper in the endless night. As you float here, perhaps noticing the gentle hum of the engine, the recycled air circulating softly, consider this: Earth is constantly, every single night, sweeping through streams of space dust. These are tiny grains, often no larger than a speck of sand, invisible from our distant vantage point, but burning up continuously in the atmosphere. They're too faint to catch the eye, for the most part, though astronomers estimate over 100 tons of this cosmic material sprinkles down daily. Countless unseen shooting stars are always there, a quiet, continuous fall of stardust. These tiny specks, remnants from comets and ancient collisions drift endlessly until a planet crosses their path. The sky, you see, is never truly still. Occasionally, however, these swift, burning visitors leave behind more than just a fleeting spark. Some create luminous, ethereal streaks that hang in the upper atmosphere, shimmering like ghostly smoke long after the meteor itself has vanished. These are known as trains, born from the meteor's superheated passage, ionizing the atmospheric gases. They can persist for minutes, twisting and curling like delicate ribbons of light as high-altitude winds sculpt them, a silent, glowing dance. You might need a moment to just float here and imagine such a sight, a magical signature written across the sky, like a reluctance to leave the stage, fading slowly, gracefully, a beautiful, ephemeral goodbye from a visitor from beyond. As we drift further, your gaze might settle upon something far more constant, a celestial anchor in the night, the moon. It's our closest and brightest companion, a mere blink in cosmic distance, yet it feels infinite in its quiet presence. Its gentle light, a reflection of the distant sun, waxes and wanes through cycles that have shaped life and time itself back on our home world. It's a silent sentinel, guiding ancient storytellers, inspiring poets, and pulling at the very oceans with its unseen gravity, creating the tides that breathe along the shores. Unlike the restless comets or wandering planets, the moon is always there, rising and setting with a soothing regularity. To gaze upon it, even from this distance, is to share a timeless view with every soul who ever lived. Indeed, those shifting phases of the moon were humanity's very first calendar. Long before carved stone or written symbols, our ancestors looked to the night sky and found rhythm in its reliable cycles. The moon's journey from a sliver to a full orb and back again, a pattern of roughly 29.5 days, provided an immediate, visible clock. Early peoples tracked it, planting and harvesting by its gentle progression, celebrating rituals under its new or full face. It even gave us the word month. This constant, visible celestial ballet provided a reliable pulse for early life, tying the heavens directly to the daily needs of survival. Isn't that just a beautiful, simple connection? And sometimes, the moon performs an even grander celestial spectacle. Occasionally, as you might observe the subtle shift in gravity around the ship, thinking of larger bodies, the moon slips into the Earth's long, majestic shadow. Instead of disappearing entirely into the darkness, it transforms, taking on a breathtaking, deep, coppery glow. This, my friend, is a lunar eclipse. The reason it doesn't simply vanish, leaving a dark void where it should be, is thanks to Earth's atmosphere. From our quiet perch out here, you can observe Earth's atmosphere performing a subtle, beautiful trick. It gently bends the sunlight, you see, thoughtfully sifting out the vibrant blues and greens, letting only the longer, richer red wavelengths slip through to reach the shadowed side of our own moon. Imagine, if you will, looking back from the lunar surface. Earth would appear as a vast, dark disk, yet framed by an ethereal ring of fiery sunsets all around its edges. That very light, crimson and deep, then bathes the moon, painting its familiar face in hues of copper and blood, reflecting back to us as the haunting lunar eclipse. It's a moment when the moon becomes both intimately familiar and profoundly alien, still serenely suspended, but transformed into something shadowed, glowing, and wonderfully strange. The faint, steady hum of the engines is a comforting lullaby around us, a subtle vibration that travels through the hull, and into your very core as we drift. This eerie red glow, these blood moons, have always stirred human imagination, long before our science could explain their celestial mechanics. You might find it fascinating how, in ancient times, people often perceived them as potent warnings. The Inca, for instance, whispered tales of a celestial jaguar attacking the moon, staining it crimson with its fury. In parts of Mesopotamia, such events were believed to signal danger for kings, leading to elaborate rituals designed to shield their rulers. Isn't that just like us, to seek meaning in the grand cosmic ballet? Yet, not all cultures saw doom in the coppery light. Some viewed the eclipse as a profound moment of renewal or cosmic rebalancing. Today, we understand the physics of it all, of course, but that primal weight, that deep, ancient feeling, it still settles upon us when we witness the moon blush red in the night sky. It's as if we're tapping into the very same awe felt by every generation before us, connecting us across millennia. You might need a moment to just float here, letting that thought expand in the quiet of the ship, the soft console lights casting gentle reflections on the viewports, a quiet marvel indeed. One of the most remarkable things about a total lunar eclipse is its gentle unfolding. Unlike the brief, fleeting spectacle of a solar eclipse, a lunar one lingers, offering a protracted, almost meditative show. The moon doesn't just snap into darkness. It drifts gradually into Earth's umbra, darkening slowly, then emerging into that coppery glow. Once fully immersed, the total phase can last for over an hour, sometimes even close to 2. During this time, you watch it hover there, wrapped in its dim, visible cloak, a muted jewel in the inky blackness beyond our viewport. The subtle shift in our ship's orientation, a barely perceptible adjustment, keeps us perfectly aligned for this extended view. Everyone on the night side of Earth, you see, has a chance to witness this, making it one of the most accessible celestial events. Ancient people would gather, sharing stories of gods and omens, and today, families and astronomers alike still marvel at this spectacle that needs no fancy equipment, just a clear sky. As the moon eventually drifts free of the shadow, its familiar silver light gently returns, and the world below feels restored, almost as if a breath has been held, then softly released. This slow, deliberate unfolding truly makes a lunar eclipse one of the most hypnotic performances in the heavens. And then there's the other kind of eclipse, the one that races across Earth with a sudden shadow. When the moon positions itself directly between Earth and the sun, a darker, more dramatic shadow falls upon the land. But this shadow, you see, is never still. From our vantage point high above, we watch it sweep from west to east across the vibrant blue and green marble of Earth, moving faster than sound, a dark, moving circle crossing oceans and continents. On the ground, the approach is unmistakable. Light dims abruptly, the air grows chill, and a sudden silence falls over the landscape. Within minutes, day turns to an otherworldly twilight. Nothing to worry about. Probably only those standing within that narrow, fleeting path of totality truly experience the full eclipse, brief window when the sun vanishes behind the moon. You can almost feel the hush on the world below, the slight drop in temperature, even from up here, carried on the recycled air. Ancient people, one can only imagine, must have felt profound fear as that rushing darkness consumed their day. But today, many journey thousands of miles, drawn by an irresistible urge to stand in that very shadow, to witness this rare, delicate geometry of three celestial bodies perfectly aligned. It's a powerful reminder of how intricate and precise the cosmic dance truly is. During those precious minutes of totality, the familiar world below transforms into something dreamlike. With the sun's blazing light completely blocked by the moon, a profound twilight descends in the middle of the day. In that strange, hushed light, stars begin to appear. You might spot Venus first, shining radiantly, impossible to miss, followed by the bright gleam of stars like Sirius or Regulus. Even Mercury, a shy planet, can be glimpsed, a truly impossible sight on any ordinary afternoon. The world below grows quiet, birds settle into their roosts, and insects begin their evening chorus, while the air cools noticeably. Overhead, for those few minutes, the sun's magnificent corona stretches outward, a delicate, ethereal crown of light, usually hidden by the overwhelming brilliance of day. To see stars burning in the middle of the day is truly startling, a sudden reminder that they are always there, patiently shining, whether our daytime sky allows us to see them or not. For those brief moments of totality, the world below feels suspended between two realms, day and night, intertwined in a breathtaking embrace. Why does the universe always do this to you? Just when you think you understand it, it shows you another impossible beauty. It's truly remarkable how long before our sophisticated telescopes and deep space probes, ancient astronomers watched the skies with such careful devotion. They noticed that eclipses weren't just random, terrifying events, but part of repeating, predictable cycles. The Babylonians, for example, uncovered the Saros cycle, a rhythm of about 18 years that allowed them to forecast eclipses with astounding precision. In China, royal astronomers meticulously recorded eclipses as omens linked to the fate of emperors, their records stretching back thousands of years. The Maya, too, aligned their grand temples with the sun and moon, building intricate calendars that perfected their movements. Even without modern science, these ancient civilizations learned to anticipate celestial events that once instilled terror in entire communities. Imagine standing beneath a darkened sun, knowing with certainty that its light would return. It must have felt like immense power, proof that a hidden order lay within the heavens. Their careful records, those quiet observations made under ancient skies, became the very foundation for our own understanding, gently turning mystery into predictability and fear into a profound reverence for the magnificent, enduring patterns of the cosmos. The subtle movement of our ship, a gentle drift, feels like a silent acknowledgement of that ancient wisdom. And speaking of celestial beacons, consider Venus. It shines so brilliantly in our night sky that from Earth, under the darkest conditions, it can actually cast faint shadows on the ground below, a trick only the full moon can otherwise perform. It's no ordinary point of light. Often, it's the very first to appear in the evening, or the last to fade at dawn, a steady, captivating lantern in the heavens. This intense brilliance, you see, comes from its thick, reflective clouds, which efficiently bounce sunlight back into space. To ancient people, Venus seemed like two separate celestial bodies, the radiant morning star and the glowing evening star. Isn't that just a little bit magical? The way perception shifts with knowledge. The view from our console, bathed in the soft, ambient glow of internal lights, allows us to reflect on sights beyond our immediate trajectory. Take Venus, for instance. From Earth, it's often a radiant beacon, a serene gem in the twilight sky, so bright it can even cast faint shadows. But from up here, knowing what we know, its beauty becomes a fascinating deception, doesn't it? Beneath that shimmering veil lies a truly ferocious world, where unimaginable heat and crushing atmospheric pressure would instantly turn any casual visitor into nothing more than a memory. A stark reminder that what appears tranquil from afar can hold the most intense secrets. Then there's Jupiter, a true monarch among planets, isn't it? Even from our cozy vantage point, with the gentle thrum of the ship's engines, a constant companion, its steady gleam dominates, outshining most of the countless stars we drift past. Its light, constant and unwavering, cuts through the constellations with an undeniable presence, a sharp contrast to the twinkling dance stars perform when viewed through Earth's atmosphere. No wonder ancient civilizations worshipped its brilliance, associating it with gods of immense power and thunder. Yet that calm, commanding glow is merely a facade for a world of incredible turmoil. A swirling spectacle of colorful atmospheric bands dominated by the truly legendary Great Red Spot, a storm larger than your entire home world, raging fiercely for centuries. Why does the universe always do this to you, offering beauty and chaos in equal measure? To simply gaze upon Jupiter, even through our enhanced viewports, is to watch a giant move in slow, deliberate motion, its undeniable presence holding your attention. It's a profound reminder of the sheer scale of our solar system, where even the most distant, seemingly tranquil glow can hide unimaginable immensity. And yet, this colossal world is not alone. Imagine, centuries ago, a simple pair of binoculars or a rudimentary telescope revealing 4 tiny pinpricks of light dancing beside it. These are the Galilean moons, Io, Europa, Ganymede, and Callisto worlds in themselves, gently tracing their paths around their colossal parent. Their discovery fundamentally changed everything, shattering ancient beliefs that all celestial bodies revolved solely around Earth. A quiet revolution, wouldn't you say? These aren't just mere points of light. No, each is a distinct world, each with its own incredible story. Ganymede, for instance, dwarfs even the planet Mercury, a surprising giant among moons. Europa, with its gleaming icy shell, likely conceals a vast, deep ocean beneath, a tantalizing possibility for life beyond Earth. Io, on the other hand, is a furious ballet of constant volcanic eruptions, a crucible of geological activity. And then there's Callisto, ancient and scarred, its surface a testament to impacts stretching back further than recorded history. Watching their quiet, graceful dance around Jupiter from our softly vibrating ship, the realization still feels revolutionary, just as it did to Galileo all those centuries ago. Proof, in gentle, slow motion, that other worlds truly do orbit far beyond our own. Next, let your gaze drift toward Saturn, a planet of such quiet, understated beauty, golden and steady in the inky blackness. It's lovely even to the unaided eye. But then, as our ship's long-range optics bring it closer, the view utterly transforms. Suddenly, before you, a world appears, encircled by a halo of rings, so impossibly delicate, so exquisitely thin, that they seem to defy physics. They stretch for hundreds of thousands of kilometers across the void, yet are so insubstantial they can nearly vanish when seen edge-on. There is truly no other sight quite like it in our solar system, is there? A whisper of wonder, framed by the faint reflections of console lights on the viewport glass. These shimmering bands are not solid structures, but a vast, intricate ballet of countless icy fragments, ranging from particles finer than dust to chunks the size of mountains, all orbiting in perfect, silent harmony. Galileo himself first glimpsed them, his early telescope too primitive to fully reveal their true, astonishing nature. Centuries later, they still captivate, a favorite spectacle for anyone with a telescope and a curious mind. But here's a thought that adds a touch of bittersweet beauty. These rings are not eternal. They are slowly, gracefully crumbling, showering Saturn's atmosphere with their icy dust. Perhaps in 100 million years, this breathtaking display will be gone. So, you might need a moment to just float here to fully appreciate this exquisite, fleeting masterpiece that space has gifted us, while the ship glides on, almost imperceptibly. And then there's Mars, the red planet. Most of the time, it drifts modestly across the heavens, a small, ruddy ember amongst the brighter stars. But every 26 months, a cosmic alignment occurs, bringing Earth and Mars into a close embrace during what we call opposition. In these fleeting moments, Mars transforms, blazing forth with a fierce, ruddy glow that can outshine even Jupiter, sometimes second only to Venus. You can almost feel its presence through the viewport. No wonder ancient civilizations, witnessing this fiery transformation, saw it as a potent symbol of war and blood, naming it after their formidable gods of battle. It's a dramatic pulse, a heartbeat within our planetary neighborhood. Through our current view and what we know from landers and orbiters, Mars reveals its secrets: gleaming polar ice caps, vast, shifting dust storms that paint its surface in ochre hues, and deep valleys unmistakably carved by ancient, long-gone rivers. During those spectacular oppositions, it truly commands attention, even from the most casual observer. But then, as the celestial dance continues, it gracefully retreats, fading back into its more modest role, its brilliance ebbing and flowing in rhythmic cycles. Each close approach renews our fascination, a tantalizing chance to gaze across the void at a world that feels both profoundly alien and yet strangely familiar, almost as if it's quietly waiting for us to one day step back onto its rust-colored soil. The ship's gentle vibration seems to echo that quiet anticipation. Now, let's talk about Mercury, a planet that truly loves its secrets. Always clinging tightly to the sun's fierce glare, it rarely ventures far enough into the night sky to be easily spotted. Many on Earth have never had the chance to glimpse it, even though it makes brief appearances a few times a year, a faint shimmer just above the horizon at dawn or dusk before dissolving back into the encroaching sunlight. Ancient skywatchers called it a quicksilver wanderer, darting across the heavens with such unusual speed and elusiveness that some cultures believed its morning and evening apparitions were entirely different celestial bodies. A true cosmic enigma, isn't it? It wasn't until Galileo turned his nascent telescope skyward that its phases, much like our own moon or Venus, confirmed its true nature, another world orbiting our star. Even today, spotting Mercury is considered a subtle challenge, a reward for the truly patient observer during those fleeting moments of its greatest elongation from the sun. For those who manage to locate that tiny, shimmering ember at the very edge of day's fading light, it feels like discovering a precious, hidden treasure. The vast emptiness outside our hull, gently illuminated by distant starlight, feels all the more profound with such shy wonders tucked away within it. Our solar system, as you can see from our vantage point, stretches far, far beyond what the ancients ever conceived, into realms where faint, distant worlds circle in profound silence. Take Uranus, for example, a pale, greenish dot barely bright enough to be glimpsed with the naked eye from the darkest, most pristine locations on Earth, though few ever do recognize it for what it is. And then, even further out, lies Neptune, fainter still, completely invisible without optical assistance. Their discoveries belong to a more modern era of astronomy, a testament to evolving technology and human curiosity reaching further into the void. Uranus was first identified in 1781 by William Herschel, an accidental discovery. Neptune, however, was a triumph of pure mathematics, its existence predicted before it was ever observed through a telescope in 1846. To gaze upon them, even with our ship's powerful sensors, is to peer at the very limits of human perception from Earth. Through the enhanced view, Uranus appears serenely featureless, a calm, pale orb. Neptune, by contrast, unveils dramatic, stormy bands of the deepest blue. These distant giants are a quiet reminder that not all worlds reveal their secrets easily. They are silent sentinels, faint and slow-moving, patiently waiting on the distant outskirts of our planetary family for curious eyes like yours to seek them out in the vast, quiet expanse. And as we drift through this cosmic tapestry, sometimes, just sometimes, a visitor arrives from the truly unfathomable depths of the solar system. A comet, a wanderer composed of ancient ice and dust, venturing inwards towards the warmth of our star, suddenly appearing as a magnificent streak across the inky canvas. Its glowing tail, a luminous testament to its journey, seems to whisper tales of unimaginable distances and forgotten eras. It's another fleeting wonder, a gentle reminder of the endless, beautiful surprises space holds, even as the subtle hum of our vessel lulls you deeper into this cosmic journey.